Okay, so here it is. Um, just a quick reminder, and obviously I can't reteach, right? But if you have a conditional statement, and you know a statement is conditional if you have the if-then part. If P, then Q, right? This is how we write um, the conditional statement using symbols. If this, then that. So it flows, the information flows this way. And then from the conditional, you can write the converse. What's the converse? You basically just flip P and Q, right? So I'll show you how to do that. Inverse, you keep it in that same order, but you put a not in front of both pieces. Contrapositive, you flip. So you flip P and Q, and you put a not in front of both. And biconditional is when you insert the if and only if, and it goes both ways. Information can flow this way or that way. Okay, so this is basically what I would suggest to have on your study sheet. The province usually has at least one of these somewhere on the exam. Is it always rewriting a statement? No. Sometimes it's just asking you, hey, if this is a conditional, which one of these four is the converse? So you have to, it's a multiple choice. Sometimes they make you rewrite it. It depends on the scenario. One thing that I want to emphasize is that the conditional and the contrapositive, they have the same true value attached to it. It's like saying the exact same thing. And the inverse and the converse also have the same truth value. Okay, so we'll discuss that a little bit more later today. So I just asked you to do two scenarios here. So the inverse, you go to your study sheet. The inverse is what? You look, it's not P. If not P, then not Q. So I'm just going to make a note here. If not P, then not Q. Right? That's what we're trying to do here. So everything that follows the if, right? This is what I consider P, the hypothesis, and this is my conclusion, that's Q, whatever follows the then, okay? So in this case, I can just keep it in that order. And so if you don't know what contrapositive is, then you did not do your homework. See what I did there? Clever, right? That's what happens when you do late night marking. You come up with clever examples, right? The contrapositive, whenever you see con, you got to flip it. So you're going to have Q, then P, and contrapositive, we got to negate both of them. Okay, so in a sense, you just take this one you just wrote and just go, just flip it, right? In this case. So I'm going to say if you did not do your homework, I'm just going to go like this for now. Okay, if you did not do your homework, don't do this on a test or exam, right? Write it out. If you did not do your homework, then you don't know what contrapositive is. All right. So, and by the way, this statement and the original conditional, you are saying the same thing, by the way. Okay. So if you want to mess with someone, you just do that. Flip it and negate, and then like I'm saying the same thing. All right. What else could I do? I could just say, write Q like this, if I just told you that, you should be able to say, oh yeah, this is an if-then statement where Q first is it's Q, then it's P. And this should be, if you go to your study sheet, what is this? This is the converse. And sometimes you'll hear people talk like a podcast or TED Talk or whatever. The converse is also true. They'll say that often. Now you know what they actually mean. It's like if you were to flip it, that's also true. Okay, so I won't do this one, but this is the converse. And whenever you have con, that means flipping. Okay, maybe that's something to help you remember. But you don't negate, so you would just go here. If you did your homework, then you know what contrapositive is. That's how you would write this version of it. Okay. And the converse and inverse have the same true value attached to it. It's like saying the same thing there. Okay, this is just review. Now we're going to take it a little. This is the last part that I still need to cover. And so just follow me on page 47. We're going to talk about truth tables and coming up with potential counterexamples. This is on 47. So there's like zero math with this part. And if you're in computer science or you're doing anything with computers, this will make sense to you. So if you don't, I will teach it as if you don't know what I'm talking about. Okay? Check for veracity, so whether or not a statement is true. Okay, that's probably a good one to highlight. Just because something phrased as an if-then statement does not make it true. Okay, we're just phrasing it a certain way. So for example, consider the following statement. If an animal is a bird, then it can fly, right? That's just a statement. This is your conditional. How do we know it's a conditional? Well, the if-then. Conditional. And the original is always like this. If P, then Q. So whatever follows the if is your hypothesis, which we call P, and this is Q. All right? Always remember that. A statement is false. Watch this. A statement is false when the hypothesis is true. Put a P underneath hypothesis. Okay? But the conclusion is false. The conclusion is Q. More on this later. So if you could find an example where you indeed have an animal that's considered a bird, but you can then show that it doesn't fly, this statement is false. You just have to find one example where it's not the case, and consider this statement false. If you want to prove that a statement is false, we need a counterexample. That's probably a good line to highlight. Isn't it somewhat true in real life? You can tell the truth every single time, but if you lie once, they'll call you a liar. Right? That's how it kind of goes. Right? So a counterexample, an example where the hypothesis is true, but the conclusion is false. I'll use a different color for that one just so it kind of sticks out. In this case, we can use an ostrich as a counterexample. Since it is a bird, but it cannot fly. So this statement right here, I'm just going to distill this. It is a bird, so the P part is true, right? But the Q part is false. So if you can find an example where this is going on, then you would say statement is false, right? False statement. You can no longer use this statement. Really, you can't use it anymore because you found a counterexample. It's dead in the water, okay? And with me saying that, I want to make sure you understand that no number of positive examples can prove a statement is definitely true. You can give me 100 birds and they all fly, right? You can give me 1,000 birds, they all fly. If you find one example where it's not the case, statement is false, right? That's just how it goes. One counter example is enough to prove a statement is false. Having fun yet? Yeah. Guess what section we dropped during COVID? They allowed us to chop down things, right? This part. But now it's back on the exam, so we can't do that. Consider the following conditional statement. If a number is prime, then it is odd. And you might say, what are prime numbers? Here they are again, right? Prime numbers only divisible by themselves, so one and themselves, okay? That's what the definition of prime numbers. So here are the first couple, okay? So if you look at this, if this is true, then it is odd. Well, 2 is prime. 2 is prime, but not odd. Therefore, false. That's the theme. If you can find something that makes the first part true, but the second part false, done, okay? Is it true? How do you know? If not, give a counterexample. I'll just say example 2. Sorry, I already kind of talked about it before. Conditional statements are very important to mathematics because they form the foundation of theorems used to prove mathematical statements, okay? So basically, in math, if you want to prove a theorem, you got to make sure there's no counterexample that messes it up, right? If you want to say a right triangle always has one 90-degree angle, right? That's a theorem, like that is undeniably true, right? That's always true. You don't have a counterexample for that. So then you can make a theorem, okay? Did you know you can win thousands of dollars if you can prove there are theorems out there that need to be proven. So if you ever get into math and that's your thing, you can make thousands of dollars proving that something is true. Hey, if you want some money on the side. Okay, you try. For each statement, try to find a counterexample. Then state if the statement is true or false. So I'm going to ask you to read these 3 and try to think of a counterexample. Try to think of an example where this is true, but this is false. If you can't, we'll say it's true, right? But give it a try. I'll just update my attention. If the number is even, then it is divisible by 4. So you can think of, I'm just going to say example 6. 6 is even, correct? Is even. Check. What is that? Even. Right? It's even, but it's not divisible by 4. Okay? So that part fails. So this is true, false, therefore false statement. And sure, you can come up with different examples. There's not just one counterexample. You could have used 10, right? 10 doesn't work either. So this statement is false. You cannot say this now, okay? If today is the last day of classes this week, then tomorrow is Saturday. What's that? False? How come? Could be a Thursday if there's an in-service, right? If there's an in-service the next day. Or it could be the last day in June, which falls on a Thursday or Wednesday, right? So this one also doesn't fly. Yeah. Today could be Thursday. Where the next day is an in-service. Friday, right? So this one doesn't fly. So it could be Thursday and tomorrow is Friday, right? So false. Sometimes you can just make a statement. You don't have to stick to one method. You can actually just write out a statement where you explain why that statement is false, given that the first part is true, but the second part is false. All right. If you live in Winnipeg, then you live in Manitoba. True, right? You can live anywhere in Winnipeg, right on the outskirts of Winnipeg. But if you're in Winnipeg, you are in Manitoba, right? True statement. No counterexample. So you know what? If the province says, state a counterexample, don't argue with them, right? They're saying there is a counterexample, just give me a good one, right? Like sometimes they just phrase it like that. They don't necessarily always ask, is there a counterexample? It's like, state the counterexample. That means that you've got to come up with one that just falls and actually applies. Okay, keep going. Truth tables. You know what? I kind of like these, but you might not. So here we go. Maybe what I will start with is this box here. This is the same as the counterexample. Okay, same thing as the counterexample. A conditional statement is false when the hypothesis is true and the conclusion is false. And I basically will say this. True, false, right, is always false. Like maybe that's gonna help you. True, false, you've lied. Okay. As soon as you activate the if part, the next part better be true or else you've lied. Okay. So here's the statement. Caleb attends every math class and gets 100% in math. By the way, guys, this is just a statement. Hold on. I'm gonna do this above it. Not a conditional, not a conditional just yet. And I wanted that to appear because sometimes the province has done this where they just gave you a sentence and it's not a conditional just yet, but we can turn it into conditional anytime we want, right? So let's turn this statement into just a conditional, and we would call this P, and gets 100%, we call that Q. So let's write the conditional. If, that's where we introduce the if, right? If Caleb attends every day, attends every class, comma, then he gets 100% in math. I would say the biggest counterexample to this one is Einstein, right? He was a genius, but he was terrible at attending. Did you know that? He actually found a university that would not keep track of attendance because he just wanted to work on his own things because that was too boring attending the math lectures. So look up his documentary; it's pretty cool. So let me explain this table to you a bit because you might think like, whoa, where did this come from? Okay, so for the hypothesis, you can be true or false, right? Same thing with the conclusion, it could be true or false. But it turns out it's just like tossing two coins. There are 4 different cases that you can come up with. 2 times 2, right? 2 options for P, 2 options for Q. So there's 4 cases. So I've laid this out. I made sure these are all different cases. So look what I did. I went true, false, and I went true, false, true. I just did that. But if you look at every single case, the first case is where both parts are true. The second case is where both of the pieces would be false, P and Q. True, false, false, true, right? So this covers all possible cases. So don't worry about this too much. This is usually given to you, but it's not necessarily in this order. It could be that true and true is snuck in the third row, okay? So don't be fixated on it has to be in this order. Now, we want to see if this statement is true. The conditional P, if P then Q. Which one is going to be the only case where you are lying, where it's false? And my pencil is pointing right at it. When the first part is true and the second part Q is false, this statement is false. All right, you've lied. Everything else is considered true when it comes to conditional statements. And you're like, what? Well, if both are true, if Caleb attends every day and gets 100%, well, obviously the statement is true because the if is true, the if part, and got 100%. What if both are false? If he doesn't attend every day and he doesn't get 100%, you haven't lied, right? Because you indeed did not attend every day. So the statement itself cannot be, you cannot say you lied because, hey, after all, you didn't attend every day. Caleb didn't. The third case is where you lie. When you say, hey, Caleb attends every day, and let's say he got a 99 in math, right? Mean teacher, right? You should bump it to 100. But anyways, that'd be false. This is the one that throws students off. How come this is a true statement? Well, this is Einstein, for example. Like if you do not attend every day, but still get 100% in math, you still haven't lied because it could happen. It could happen that you get 100%. You just didn't attend every day. So you didn't break the if part. The if part is what activates the statement. So if you activate it with a true, you better have another true here or else it's false. Okay? I know you're scratching your head. I can hear it. But anyways, this is the only false statement right here, where true, then false. If P is true and this is false, that's false. Everything else is true. Maybe sometimes just trust me. And then I'll explain it more as the semester goes by. Let's go over here, guys. Let's go over to this one. This is the contrapositive. Okay, let's write the contrapositive first. Make sure you write this down. If Caleb does not get 100% in math, then he does not attend every math class. He does not attend every class. So what have you just done, guys? To go from the conditional to the contrapositive, remember you got to flip the order and you got to negate both of them. So please pay attention to this part. So we're going to start filling in not Q. You're with me, right? So what do? We go to Q over here. If you put a not in front of Q, it's like you changing the sign, quote unquote. So if it's true here, what is it going to be over here? False. If it's false on the original and you negate it, you change it to true. So that's what the not does. It changes it to the opposite true value, okay? So instead of true, false, false, true, we have false, true, true, false. We just negate. So we take this Q and we put that negation in front of it. So we change the, and then the same with P. We're going to take P over here from the original and we're just going to switch. If it's true, we change it to false. If it's false, we change it to true. Because that's ultimately what we have done. Okay? So this is now saying if not Q, then not P. We've done the nots. We've changed it from here to here. Which case is going to be the only one where you've lied? Look at case 3. True, false. This is the only one that's going to be false. All the other ones are going to be true. Do you see? Remember when I told you you're saying the same thing? You see them side by side. It's true, true, false, true. You're saying the same thing. Okay, that's why I wanted it like this, side by side. Okay, saying the same thing. That's why I wanted them side by side. Yeah. You mean, okay, so basically what I did is, because to make a contrapositive, you flip the order and you put a not in front of both. So I took P and Q, I flipped it, and then I put a not in front of both. So we basically just take these ones and flip them around, and it just ends up being that it's like that. That's why I did it side by side. This is my best attempt at letting you see that they're saying the same thing. All right, visually. Remember, a lot of you said, I need visuals. I'm a visual learner. Here it is, right? This is, and you're like, still, I don't. It's okay. I'm very confident that by the end of the semester, I'll have this, you'll have a pretty good grasp. Okay, let's keep going here. Converse and inverse, they say the same thing. Okay, so let's write the converse. Q first, then P. So if Caleb, how does this go again? If Caleb gets 100% in math, then he attends every day. Perfect. I'll do the inverse right away as well. The inverse is just negating P and Q. If Caleb does not attend every day, every math class, is this English or math? Then he does not get 100% in math. So I've rewritten them. This is just to practice, keep practicing what we did yesterday already. Technically, this should be pretty doable for you at this point. But let's fill in the true tables. And you know why these are blank? Because I'm going to base it on the very original conditional. So, sorry, I'm going to scroll up again. Copy down the Q, like Q, copy these ones down over here. So it's going to be true, false, false, true. True, false, false, true. And then copy down P into here. So it's true, false, true, false. I'm going to use a highlighter here because I feel like you're going to look at this in June and be like, what? So I'm just, maybe watch me do this first, right? This came in here. And this came in here. That's what happened, right? I just literally took the original and just flipped the order, okay? If I had $100, I'd offer you $100. But which one of these statements is false? Look at these 4 cases. The pink doesn't do very well. You can see from the side here, it's hard to see. Which statement? Yeah. You can just show me with your hand. 4, 4. All right. Yes. It's an if-then statement, right? How do you know? Right there. Because sometimes the province doesn't do this part. They just literally give you this. It's like, hey, fill in this truth table. And you're going to be like, oh, it's conditional. It's this, if this, then that. So true, false, I would focus on that first, and then everything else is true. Okay. Now we're going to do this part. And what does the not do? It just flips it. Okay. Sorry, I should be careful with flipping. It just changes a true to a false and a false to a true. That's what it does. So I'm going to take this. I'm going to go false, true, false, true, right? So I've ran down this here and I just changed it. And then Q is false, true, true, false. There you go. Which is the only one that's false here. Yeah, there we go. False. Everything else is true. You see that? Side by side, can you see that they're saying the same thing? Case 1 is the same, case 2 is the same, case 3 is the same. Case 4 is the same as well. They're both false. So same thing. Okay. They're saying they have the same logic to it. Okay. And I say that one more time here. I do say that one more time. If you don't mind highlighting that, they're essentially saying conditional contrapositive are saying the same thing. Converse and inverse are saying the same thing. I'm almost done. You got this, guys. You got this. Remember, arrow is if then. Okay. I'm going to change this up a bit. I think the next statements are going to be a little bit easier to understand why it's true or false. So let's go to page 49. Page 49. And watch what it says, and or statements. Angela wants to go shopping and watch a movie afterwards. And is the symbol like this, but in a truth table, you see that? You see it's like a hat. It's the same thing. So and is like the intersection, or it can be written like that. Okay, don't let that throw you off. Go to your study sheet and just make next to this one have that little hat there maybe. So if you get a truth table like this, you don't even need this statement. I just give you a statement where I say, hey, this is P and this is Q, just so you can kind of wrap your head around a context. But the only time you won't lie if you use and is if indeed you do both things, correct? If you say I'm going to do this and that, the only time you're not lying is if indeed you're doing both things, right? So we're going to go, and this is the only time where this statement is true. I'm going to circle it because that's unique, right? I circled the unique parts. Everything else, if you don't do both of them, obviously you've lied. If you go shopping but you don't go to the movie afterwards, you've also lied. If you've not gone shopping and only went to the movies, you've also lied, right? So both have to be true. Hey, you want a Venn diagram for this? Only what happens in here, right? When you do both things, it's going to be true. So this would be going shopping, going to the movie. So let's say you collect a number of days. You've done some shopping some days, you've gone to the movie some days, but this is the days where you do both. That'd be considered true. Do you need me to, I will just say here, with and, both parts need to be true for the statement to be true. And here's the or. When you're given or, watch this, with or, only one needs to be true for the statement to be true. And notice the or is a V, right? It's or is like the union like this. It's the same thing. They all mean or. Okay. So if it's pointing up, it's union, it's or. So the only time that you're lying here, so if you do both of them, good for you, right? Go shopping or watching a movie, you've done both, you haven't lied. If both of them are false, that's when the statement is false. If you only go shopping but you don't go watching a movie, you still haven't lied because you said or. I'm going to do this or that. If you don't go shopping but only go to the movie, you're still doing okay, right? So the only time that you've lied is if both are false. And this is the last table I'm going to do here. The rest I will get you to try. I might make a video for this homework because I can see that some of them you might get stuck, but it's not that hard to get unstuck. Okay. Biconditional. Both parts must be true for the statement to be true. Because biconditional is saying if P then Q and if Q then P. That's what biconditional, like it goes both ways. Okay? It goes both ways. So the only way a biconditional is true is if indeed both parts are true. Okay. So true, true, true. Everything else is false. Okay. Yeah. Biconditional has to go both ways. How do you know it's a biconditional? If and only if. And the arrow going both ways. Sorry, this arrow, like it should be connected. I just couldn't find a symbol on Word. Okay, it's just one line here with arrow going both ways. You know what? I'm looking at this. I'm not so sure about this one. Give me 1 second. I lied to you. When both are false, the statement is true. So I need to make an adjustment here. This is what I'm going to adjust here. Just scratch this, because this might confuse you, because you're going to be, oh, if both are true, then okay. I want to show you something here why this is true. Okay, look at case 3. If you're going from P to Q, if true then false, then it's false, right? If you're going from Q to P, which is what's happening here, because the information flows both ways, as soon as you have a true first part and the second part is false, then the whole statement is false. So both of these are false. However, this is still going to be a true, because no matter which way you come at it, you're not activating the if part. The if part is false. And if the second part is false, it's okay. So no matter which way you come at it on this perspective, so yeah, biconditional, it goes like this. Okay. That's all I can say here. Like if true false, right, then it's false. If true false this way, then it's also false. Right? So you gotta watch out there for that one. Thank goodness we have Google. Okay? All right, it's been a while since I did this. Anything else? This is it. This is it. So what I will do is I'll ask you to try page 50. I know they look scary, but I will explain a little. Page 50, and I will just tell you that the logic goes all the way to 56. And you're like, what? It's all multiple choice. If you want to test your knowledge, uh, anything past 50 is all just multiple choice. So if you want to test your knowledge on conditional statements, that's where you do it. Let me help you with this, set you up here. So on page 50, I give you the P and the Q, and I give you the 4 cases, and I give you some slots to fill in this case, the knots. All right. And then I will also ask you, what's this saying? P and Q. So I want you to fill in the true values here. And if it's P and Q, you obviously are going to these here. What is this one saying? This one is saying P or. This is or, this is and. Okay, remember that. So you're going to just fill in the true values based on P and Q here. And you might ask, what about this, Mr. Dirksen? What's this? Right now, it's just, do you know what that means? What should you be doing? Is you literally just change true to false, false to true, and just copy it down because I need you to be familiar with that. And then I have a couple of if statements. You got to watch out, right, for these ones because in this case, the information is flowing that way. And Q to P, technically, if you go back to this, the information is flowing that way. So you want to be looking for true, false, going this way to make that false. Okay. So give this a try. Try this truth table here. And that's it for today. I'll hand back the quizzes. And what I will do with the quizzes, I'll just give you, maybe I'll just go over it briefly towards the end. And I'll scan the key and post it on Google Classroom. And then It's this. If this, then not Q. So I'm going to look at these two here. I know the arrow goes from left to right here, but I'm going to look at it going this way. Okay, because it goes from here to there. It's the only one that's false. I'll help you out here. Yeah, if you had done not even a sentence as households, I would have been fine. Yeah, it was done well. It was done well. It's just that's what the province would do. Okay. Yeah. I'm trying to help you out here. But for the very last one, you see how the arrow on the paper goes from left to right? But think of it this way, it goes from orange to pink. So over here, I've done orange, pink, and technically you should be thinking as the information flowing this way, right? To get this right. And the only way that has true then false is the first row here. That's why you have it false. So, and it all started with me coming up with the and here, right? I had to figure this out based on the very first one. So